And it's a good explanation right here from chapter 1 of your book that um, you will have a research question that you want to answer. And a lot of times, the way you will answer this is by collecting data on the topic. And once you have the data, you need to analyze the data. And so you'll organize it, display it. Um, you will find things like the mean and the standard deviation. So you'll look at descriptive statistics from your data, and that's all inferential. That's descriptive statistics. And once you've done that, ideally, you would like to be able to draw some conclusions. And this is called inferential statistics. And that will be our next topic. So, um, the how can we best collect data? This is some good reading that you should do in chapter 1. I do not cover it in the lectures, but it is your book is a good resource if you actually have to do your own experiment. You need to put some thought in how can you be assured that you have a random sample. That is important. So you need a randomized sample. Make sure that you are collecting your data in the best possible way. We're going to focus more on how it should be analyzed and what we can infer from the data. So this is just a short lecture to introduce, sorry, my iPad just cut off. This is a short lecture to introduce you to the different types of data. Um, this is important sometimes when you're using software. It will ask you for what type of data that you're using. And I remember when I was first starting out, I was like, I don't know if I have nominal data or ordinal data, or is my data continuous or discrete? So it's worth spending a little time getting used to these terms. So data falls into two basic categories, numerical and categorical. Numerical data is also called quantitative, so you may hear that word instead. And categorical data is sometimes referred to as qualitative. So let's talk about numerical data first. There are two kinds of numerical data. Either your data is continuous or discrete. Now, continuous data is also called interval data. It has no obvious breaks. Um, so you might talk about heights of newborns. And sometimes it's hard for people to see why this is continuous. Continuous does not mean it can take on any number, but it could take on any number within some interval. So that's what makes it continuous. Now, discrete data has obvious breaks, but it's still numerical. So we will look at some examples, but just off the top of my head, um, maybe your shoe size. So unless you go to a person who makes shoes, you have to buy shoes that come in specified sizes. You can't get a size 6.203. You have to choose a 6 or a 6.5. Okay, over here, categorical data um, deals with characteristics that can't be measured but can be observed. So, like hair color, it's not numerical, it's a characteristic. And it's also nominal because nominal comes from the word name. Ordinal, think of order. So nominal data has no obvious ordering, and ordinal data does. It has a natural order. Um, an example of that might be if you take a survey and it's like disagree, uh, agree, strongly agree, that kind of thing. There's a sort of a natural order to it. So we're going to look at some examples and see if we can figure out what category these examples fall into. So, height. Height in general is always continuous numerical data. So this is numerical and continuous. The same with temperature. Now, we're only limited by our measurement tools, but temperature can take on any number within a range of values. So this is numerical and continuous. Shoe size. Well, you might want to say that's categorical, but I would say it's numerical because you could find out the average shoe size of a basketball team, for example. But this is discrete. Now, blood type, that is definitely categorical, isn't it? And is it nominal or ordinal? Is there any order to blood type? I don't think so. So I'm going to say this is nominal. Earthquakes. Earthquakes are a little confusing perhaps because you don't hear too much other than one decimal point, like it was a 7.2 on the Richter scale. But the Richter scale is continuous. So this is numerical and this is continuous. Hair color, I think you would agree, is not numerical. It's categorical. And again, it's nominal based on the name. There's no order to hair color. Let's see. Weight of newborns. Weight, like height and temperature, is continuous. Let me write this a little better in case you confuse. We'll call these CAT instead of just because it might look like that said continuous. So that's categorical and nominal. So weight of newborns, like height and temperature, is numerical data. It's continuous. Humidity, well, that's usually presented in a percentage, but that is a numerical statistic, and it would be continuous. Humidity doesn't have any set breaks. It's not either 10%, it doesn't jump to 20. It could take on any number in between. Okay, what do we have over here? Responses to a satisfaction survey. So this sometimes is called a Likert scale. You will run into that kind of language. This is categorical and this is ordinal because usually there is some kind of order to these responses from the strongly disagree up to the strongly agree. It's not always. You might have some surveys that are nominal. So All right, look at this. Rolling, the results of rolling 2 dice. Well, definitely that's numerical because that's going to be a number. Um, but you can't get any number, so it's going to be discrete, right? When you roll 2 dice, you can't roll 2.5. Okay. The number of students sleeping in stats class. Well, that's going to be numerical, and that's going to be discrete because either you're asleep or you're not. Well, maybe you might say you're half asleep. Ha ha ha. That was, it's funnier in person. Oh, okay. Time spent waiting in line at a bank. Now, that time is continuous. Time is numerical and continuous. Speed, that is also numerical and continuous. Favorite ice cream color? What do you think? Ice cream flavor. I said color, didn't I? What's your favorite ice cream flavor? That is categorical, and that is nominal. Vanilla, strawberry, chocolate, that kind of thing, based on the name. Hat size? Well, you could talk about the average hat size. That's sometimes how I think about it. If you can average the data, if you can find an average for your data, it is numerical. Now, hat sizes um, come in discrete or certain sizes. Unless you have a hat custom made, you're going to have to choose your hat size. Okay, so think about these and make sure they make sense. And you might say, okay, why is this important? Well, depending on what kind of data you have, that determines how you analyze it. Um, you can't talk about average hair color or average ice cream flavor, but you could talk about what we'll learn is called the mode, which is the most favorite ice cream, or which hair color occurs most often. And with categorical data, you use like bar charts and tables. You can use pie charts. Your book does a good overview of a lot of different ways to display data. And that's what we're going to talk about in the next lecture. So take a little break and keep going.